In 1977, something rare was about to happen. Every 176 years, the outer planets align on the same side of the solar system. Jupiter, Saturn, Uranus, and Neptune lined up like stepping stones. It had last happened when Thomas Jefferson was president. NASA called it the Grand Tour window, and they had one shot at it. Miss it, and no one alive would see it again. So they built two spacecraft, small by any measure, about the size of a small car, powered not by solar panels. Out here, sunlight is too faint, but by the slow decay of radioactive plutonium, enough heat to generate electricity for decades. They named them Voyager. Voyager 2 launched first on August 20th, 1977. Voyager 1 followed 2 weeks later, on a faster trajectory that would overtake its twin within months. They were sent to observe, to take photographs, to measure magnetic fields and particle counts in places no instrument had ever reached. No one fully understood what they would find. 18 months after launch, Voyager 1 arrived at Jupiter. What it sent back stunned everyone. The Great Red Spot, a storm that had been raging for at least 3 centuries, was not a flat feature. It was a towering vortex, larger than Earth, with internal winds exceeding 600 kilometers per hour. Jupiter's moon, Io, was erupting, actively. The first active volcanoes ever seen beyond Earth, plumes of sulfur shooting hundreds of kilometers into space. And Europa, a smooth, cracked moon beneath which, scientists suspected, a liquid ocean might be hiding under the ice. In a single flyby, the solar system became a far stranger and more interesting place. But the probes weren't stopping. They used Jupiter's gravity the way a stone uses a sling, approaching from behind, falling into the planet's gravitational field, and being flung forward at increased speed as they swung around. No fuel burned, no engine fired. Voyager 1 gained roughly 35,000 kilometers per hour from Jupiter alone, enough to reach Saturn in just under 2 years. This is the elegance of orbital mechanics. Gravity isn't just something to escape. In the right geometry, it's a free engine. In November 1980, Voyager 1 reached Saturn. The rings, which from Earth appear solid and smooth, revealed themselves to be a system of breathtaking complexity. Thousands of individual ringlets, gaps carved by the gravity of moons, braided rings twisted by shepherd moons orbiting alongside them. Saturn's moon Titan was wrapped in a thick orange haze, an atmosphere denser than Earth's, hiding a surface that scientists wouldn't see clearly for another 25 years. After Saturn, Voyager 1's path bent north, up, and out of the plane of the solar system. Its grand tour was over. It would see no more planets. From here, it would just keep going. Voyager 2 pressed on, alone on a trajectory no spacecraft had ever taken, toward Uranus. In January 1986, Voyager 2 reached Uranus, a planet so tilted on its axis that it essentially rolls around the sun on its side, its poles facing the sun in turn for decades at a time. It found 10 previously unknown moons. A magnetic field tilted nearly 60 degrees from its rotational axis, a planet stranger than any model had predicted. Three and a half years later, in August 1989, Voyager 2 reached Neptune, the farthest planet, 4.5 billion kilometers from the Sun. Neptune had storms, a great dark spot, smaller than Jupiter's but just as fierce. Winds measured at over 2,000 kilometers per hour, the fastest in the solar system. After Neptune, Voyager 2 followed Voyager 1's lead, into the dark. On February 14, 1990, mission controllers sent a command to Voyager 1. Turn around. From 6 billion kilometers away, so far that the transmission took over 5 hours to arrive, Voyager 1 turned its camera back toward the inner solar system and took one final photograph. In the image, the sun is a distant point of light. The planets are barely visible. Earth appears as a single pixel, a pale blue dot suspended in a sunbeam. Carl Sagan, who had pushed for this photograph, wrote, "That's here, that's home, that's us." Then the cameras were shut off permanently to save power. The probes kept flying. In 2012, after 35 years of travel, Voyager 1 crossed the heliopause, the boundary where the sun's solar wind gives way to the interstellar medium, the edge of our solar system, by the most meaningful definition we have. No spacecraft had ever been there before. Voyager 2 crossed the same boundary 6 years later, in 2018, giving scientists 2 separate measurements of what that boundary actually looks like. As of today, Voyager 1 is more than 23 billion kilometers from the Sun. Traveling at 17 kilometers per second, still transmitting, the signal takes over 22 hours to reach us. It is the farthest human-made object in existence. Both probes carry something. Attached to each one is a gold-plated copper disc. On it, greetings in 55 languages, music from 27 cultures, the sound of rain, of surf, of a mother's first words to a newborn, a map showing where Earth is, instructions for how to play it. It was never really meant to be found. It was meant to say, "We were here, and we wanted you to know." Voyager 1 will drift through interstellar space for tens of thousands of years before coming close to another star, long after Earth has gone quiet, still moving, still carrying us with it.